In questions 2 through 6, we'll just practice a little bit more with what we saw on question number 1's video, or if in general you just kind of understood this from the Desmos, a basic look at how to interpret where an exponential graph is located based on its locator point, and how to then make sure that we can make its sketch. So in question number 2, the first thing I want to look for is the locator point. It's not asking me for it, but I think it's always a good idea to write it down just because it helps. The locator point is always the x-coordinate and the y-coordinate that we call the h and the k. The x-coordinate is the one attached to the power of x, so that would be -2 in this case. Since there's no y-coordinate afterwards, or k-coordinate as we usually call it, we can infer that its value is 0. So the locator point on this graph must be at -2, 0, which is here. Now that's not where the graph itself, the curve itself, is going to go. That's where the asymptote is going to occur. And that means that this is essentially where we are redrawing our new axes. You'll see that one of the axes didn't really change. I'm just drawing over it just for reference. But since the x-axis didn't change positions based on the locator point, I still drew it, just visual, but you don't have to. The y-axis definitely changed locations. And that's important because remember, it's off of our new y-axis that we will base our y-intercept. According to this equation, the y-intercept is 3. So I'll go up 1, 2, 3 on my new y-axis, and I'll make a dot there. Then I'll look at my multiplier. My multiplier is 1/2, which is definitely less than 1. So since 1/2 is less than 1, that's a decreasing exponential curve, which means it starts out on the right-hand side, kind of spiked up, and then flattens as it goes towards the right. Now, it's where the flattening occurs that dictates where the asymptote is. So I'm just going to notice here that the asymptote flattens out at the x-axis, or if you want to write its equation, y equals 0. So the asymptote will generally be y equals something, and it's the y-coordinate on the y-axis that you'll use. By the way, I should mention also that the y equals, that's based on the original y-axis. So even though you shifted for the translated graph, the asymptote is still in theory going to be based off of a traditional number line. I'll do one more just to make sure that you have the idea, but hopefully this is getting a little bit easier as you think about it. In question number 3, I'll start out with the locator point again. I'll look for h and k first. H is always the number in the exponent spot with the x, so that's 1. K is always the number after that, so +2, and that means over 1 up 2. That's where my new x and y axis will be set. So I'll draw my y-axis and my x-axis. I like to make them dotted just so they're not super egregious, but you can make anything that you want to. Now, let's think. We've taken care of the x minus 1 and the +2. Now all that's left is supposed to be the y-intercept, but I'm looking at it, I don't see a y-intercept. I know that the 3 must be the multiplier because it's the base of the exponent. That's how multipliers work. It's always the base of the exponent. And I can't see an initial value or a y-intercept. But it is worth remembering that technically there could be an invisible 1 outside of this equation on the left multiplying the 3, because you would never know. 1 times 3 is still going to look like a 3 at the end of the day. So I'm going to infer that there really was a 1 there, and that would be my y-intercept. The 1 is probably what they're talking about. So from my new locator point on my new y-axis, I'll go up 1, and that will be my y-intercept. Now, since my multiplier was 3, that's going to make things increase because 3 is bigger than 1. So that starts out flat along the asymptote and then curves up through our new y-intercept. Now that I can see it, I'll look at carefully where that flattening occurred. That flattening occurred at the old y-axis up at 2. So the equation of that asymptote is y equals 2. If you've gotten to the point where you're like, oh, Herbert, I'm seeing a pattern here, that's always awesome. If you notice something, the k-coordinate, so I'll just kind of highlight it so you can see it, the k-coordinate is always the number that ends up in the asymptote equation. So k-coordinate 0, y equals 0 was the asymptote. k-coordinate is 2, y equals 2 was the equation of the asymptote. In the example that in question number 1 we did, the k-coordinate was 3 and y equals 3 with its asymptote. So it is worth noting that you can probably just do the asymptotes without having to actually wait on them, and that might be a good thing to get out of the way when you're answering a question. For example, in number 4, if I look at this, I can tell that the k-coordinate is going to be the -1, so I know that its asymptote is going to be at y equals -1. If that's easier for you than doing a whole bunch of extra work and thinking, definitely think about it that way. In any case, hopefully you have enough information now to finish questions 2 through 6. Question number 7 is going to ask you to come up with your own equations for curves that have an asymptote at y equals 2. You can make any equation you want to. All you need is something that has an asymptote at y equals 2. Number 3 already has one. So think about it. What could you tweak in that one to make your own equations, but to not necessarily change the thing about the asymptote? What are you allowed to change? And experiment with it. If you're not sure if a change is still going to work, like if the asymptote is still going to be in the right place, open up a tab in Desmos, regular Desmos, just desmos.com/calculator, and type the equation that you think you want to try. See if it flattens out where you think it's supposed to flatten out. And if it does, then use whatever equations you come up with. You can do as many as you want, but it's only going to ask you for 3 here. So finish numbers 2 through 7, and in the last video, we'll talk about the matching exercise in number 8.